Okay, so now we are going to get to proving some of these theorems. We are going to prove the vertical angles theorem. We want to prove that angle 1 is congruent to angle 3 with the diagram given. So let's get started. Step 1 is always your given. We're given the diagram. Step 2. Look at angle 2. Angle 1 and angle 2 are a linear pair, and angle 2 and angle 3 are a linear pair. This is going to help us. That's just the definition of a linear pair. Now, what do we know about linear pairs? We know by the linear pair theorem that they are supplementary. So angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. Lastly, if I know that both angle 1 and 3 are supplementary to angle 2, then that means that I can say that they are congruent to each other by the congruent supplements theorem. This is the short way to do this proof. Now, if you wanted to do it a little bit of a different way, here is an alternative. So we start off the same. We start off with the diagram. We start off saying that angle 1 and angle 2 form a linear pair, and angle 2 and angle 3 form a linear pair. That's just a definition of a linear pair. And we also use the linear pair theorem. But now, instead of using the congruent supplements theorem, which you may not remember to use, there is an alternative method that we can use. We know the definition of supplementary angles. Measure of angle 1 plus the measure of angle 2 equals 180 degrees. Measure of angle 2 plus the measure of angle 3 equals 180. That's the definition of supplementary. Since they're both equal to 180, we can set them equal to each other, either using the substitution or transitive property of equality. You do not need both. And since both sides have the measure of angle 2 using subtraction, we can get the measure of angle 1 is equal to the measure of angle 3. And then lastly, using the definition of congruence, we can say angle 1 is congruent to angle 3. This is an alternative proof. And while it is longer, it is more algebraic. So if you prefer the algebraic proofs, you can go ahead and use this proof to prove the vertical angles theorem. Now, when we're proving a theorem, we cannot use it in the proof. So notice I did not use vertical angles in the proof because I can't. I'm trying to prove that theorem. All right. Corresponding angles postulate. This is not a theorem, but you will be expected to explain the corresponding angles postulate and how it works and how we know that corresponding angles are congruent. So we're actually going to use the property of translation. We are going to translate angle ABC down along vector BA to form angle A prime, B prime, C prime. What that means, vector BA is going this diagonal route, okay? So we're going to translate all of the points the same direction and the same distance. So if I translate B down by vector BA, B prime now winds up right here. A prime winds up right here. And C prime going down slightly to the left winds up right here. And so we wind up with angle A prime, B prime, C prime when we translate angle ABC down. Now, translations preserve angle measures and create parallel lines. We know that. So what that would mean is that BC, ray BC, would be parallel to ray B prime, C prime. And we would also know that angle ABC would be congruent to angle A prime, B prime, C prime. Thus, since angle ABC and angle A prime, B prime, C prime are corresponding angles in this new figure that we just drew, this explains the corresponding angles postulate and why it works. All right. we are going to prove the alternate interior angles theorem. Angle 3 and 8 are considered alternate interior angles, and so are angles 1 and 6. We are just going to prove one pair of angles. I'm going to prove angles 3 and 8. All right, so we know that lines G and H are parallel. That's our given. That's what we start with. Now, steps 2 and 3 can be mixed around, but what I ended up doing is I ended up proving that angle 3 and angle 4 were congruent by the corresponding angles postulate. You could have also used angle 8 and 7. That would have been okay. But then also I know that angle 8 and 4 are congruent because those are vertical angles. So since both angle 3 and angle 8 are congruent to the same angle, then that means that they would be congruent to each other. That's the transitive property of congruency. You cannot use substitution there. You could have switched steps 2 and 3. You could have also used 8 and 7 as your corresponding angles and 3 and 7 as your vertical angles. It was up to you what you wanted to use. Now that we proved the alternate interior angles theorem, we're not going to do the alternate exterior angles theorem, but you may have to do that on your homework, so you're going to use this as a guide to help you prove the alternate exterior angles theorem. Moving on to our last proof, we're going to prove the same side interior angles theorem by either proving that the measure of angle 1 plus the measure of angle 8 equals 180, or proving the measure of angle 3 plus the measure of angle 6 equals 180. I'm going to do the measure of angle 1 and 8. You don't have to do both. So step 1, we have our given. Step 2, what I'm going to end up doing is I'm going to use angle 1 and angle 2. You could have used angle 7 and angle 8. And angle 1 and angle 2 are corresponding angles. So by the corresponding angles postulate, they're congruent. But in order to deal with equal signs or equations, I'm going to need to switch this congruent symbol into an equal sign. So I'm going to say the measure of angle 1 equals the measure of angle 2. That's the definition of congruence. I also know that angle 2 and angle 8 are a linear pair. That's the definition of a linear pair. And what I know about linear pairs is using the linear pair theorem, they are supplementary. And if they are supplementary, using the definition of supplementary, the measures summed together equal 180. So then going back to step 3, I now have the measure of angle 1 equals the measure of angle 2. So what I can do is I can take the measure of angle 1 and substitute it in for the measure of angle 2 here. Substitution is the only thing that works, no transitive property. But that proves exactly what I was trying to prove. The measure of angle 1 plus the measure of angle 8 equals 180. That is it. Now we did not get to prove the same side exterior angles theorem, but you can do that on your homework or on your worksheet using this as a guide.